Please open in your learning workbook to page 225. We're going to solve some problems that you might see in ALEX regarding exponential growth and decay. Suppose that $2,500 is invested at an interest rate of 2.5% per year compounded continuously. After how many years will the initial investment be doubled? Do not round any intermediate computations and round your answer to the nearest hundredth. Okay, so when we see a problem like this, the first thing you want to pay attention to is this. Does it contain the word continuous or continuously? Because if it does, then the formula that we need to use is this formula. A equals PE to the RT. Okay, so continuously says we should use this formula. Now, we're going to identify the values of the variables. A is the amount you'll have in the future, P is the amount that you have now, R is the interest rate, and T is the length of time. So we're going to read the problem again, then fill in everything that we can as we go. Suppose that $2,500 is invested. Okay, that's P. At an interest rate of 2.5%. Well, 2.5% has to be converted to a decimal. Percent is a mathematical constant. It's a symbol that always represents the same value. As a decimal, the percent symbol is the number 0.01. So when we take 2.5 and multiply it by 0.01, we get 0.025. This is R for this problem. So we'll have 2,500 e to the 0.025. Let's keep reading. After how many years will the initial investment be doubled? So the question is after how many years? That's T. T is the unknown. And it says the investment will be doubled. Well, doubled means multiplied by 2. $2,500 times 2 is $5,000. So that's A, the amount of money in the future. Okay, great. Now all we have to do is solve this equation for T. Let's begin. All right, the base of my exponential expression is E, which means this 2,500 is extra and I need to get rid of it. So I'm going to divide both sides by 2,500. This is an exponential equation of type 2. So the method that I need to use is to get this in the form exponential of type 2. So I need to get this into the form base raised to exponent equals something, and then take the logarithm of both sides. So I have 2 equals e to the 0.025t. Okay, so that matches this form. Base raised to exponent equals something, base raised to exponent equals something. So the method we use to solve a problem of this type is take the log of both sides. Because this question asks us for a decimal, if it tells us to round to the nearest hundredth, then we need to take the log base 10 of both sides or the log base e of both sides. It's our choice. But because this problem includes base e, it's logical to choose the natural log, the log base e. So we're going to take the natural log of both sides. So then we'll have the natural log of 2 equals the natural log of e to the 0.025t. Now in the previous 2 videos, I showed how something that looks like this gives the result 0.025t. So in this video, I'm not going to show those steps. I'm simply going to show the result. So I get the natural log of 2 equals 0.025t. To get t alone, I have to divide. So divide by 0.025 here and here. So this gives me the exact value of t. T is exactly equal to the natural log of 2 divided by 0.025. This is my final exact answer. But the problem asks me for a decimal approximation rounded to the nearest hundredth. So this is where I'm going to pick up my calculator. I'm going to make a fraction. In the numerator, I'll put the natural log of 2. In the denominator, I'll put 0.025. And I get the result, t equals 27.725888722. Since I need to round to the nearest hundredth, this is going to give me that t is approximately equal to 27.73 years. Okay, that is the end of this problem. Now, let's learn a life lesson based on what we've learned in this problem. If you are investing money at a rate of 2.5% per year compounded continuously, it takes 27 years for your money to double. So the power of investing is the long-term nature of investing. You want to invest as much of your money as you can when you are young in an interest-bearing account, a retirement account, so that it has time to grow and grow and grow, so that when you need it in your end-of-life days, that money is ready for you.